Okay, let's go to the last part of this lab. Action item number 8. Router 1 wants to have all traffic coming and going through router 2. So notice that router 1 has a multi-homing scenario here. It is connected to the world using through router 6 and through router 2. So router 1 wants this link to be the active link and this link to become the passive. So how to do that? So first of all, we already have this in place. Show IP summary. So this is already in place. So I'm going to delete the aggregation that was created in another part of the lab. So we can configure this active and passive configuration. So let's go to router BGP and address IP4. I'm going to delete the aggregation and this aggregation as well. I'm going to delete it. So let's see. So IP BGP. Now notice that router 6, for instance, is receiving the same prefix from two sides. It is receiving router 1 prefix from router 2 and from router 1. So in this case, router 6 is performing the BGP best path selection algorithm, and at one point in the algorithm, it will compare the as path. So in this case, this route has a better as path than this one because this as path is larger. So as part of the BGP best path selection algorithm, the as path that is has fewer members is preferred. So this is why, even though I have two paths to the same destination, this path is being preferred. So that is why if I ping this IP address, I will go directly to router 1. So I will be using this link, but this customer does not want this link to be used. This customer wants that this link to become the active and this should be passive. So how do we do that? So first of all, we have to control the egress traffic and then control the ingress traffic. So for instance, this issue happens as well in router 1. If router 1 wants to ping an IP address that lives in this autonomous system, it is reachable, but it is reachable directly to router 6. We don't want that. We don't want to use that link. So we have to control the ingress and the egress traffic with BGP in order to accomplish this. So let's create a roadmap. That will be for querying with router 2 permit and the sequence 20. If I will not include a match statement. If I don't use a match statement, that means match any. So I will use set local preference. I will increase the local preference for all the routes that come from router 2. That will let me influence the egress traffic. So I have this roadmap now, that the only thing that this roadmap does is for all the prefixes, it will set them to local preference 110. Remember that by default, all prefixes have a local preference of 100. Let's, for instance, see this. Local preference is 100. And what I want to do is influence my egress traffic with the local preference. So I'm going to apply this roadmap to router 2, to the router 2 peering. So let's go to router BGP. Other some of the IP before, and for the peering to router 2, this is the IP address of router 2. I'm going to roadmap it with this peering with router 2 in. So I'm going to apply this roadmap to incoming routes. So that still is not happening because I have to reset the session. So notice that for the time being, routes coming from router 6 and from routing 2 have the same local preference. So let me clear session with router 2. This was a hard reset. Probably I had to use this command, but too late. It's too late now. So notice now that I made the change. All the routes coming from router 2 have this local preference. So they are picked because BGP is running the BGP best path selection algorithm, and it will come across that this preference coming from router assigned to the prefixes coming from router 2 are better than the prefixes coming from router 6. So for instance, if I issue this command, I can see that, for instance, this route has two options, has two paths, this path and this path. And even this path has a higher local preference. It is preferred, but it is the best. So now, if I wanted to trace route this IP address, I will go through router 2 rather than going to router 6. So the egress traffic is controlled. So what I want to do now is to control the ingress traffic. And in order to do that, I'm going to do another roadmap. That will be pairing with router 6. Permit. So I'm going to avoid issuing the match statement, and I will only do set as path PREPEND the autonomous number Okay, so I'm going to prepend my own autonomous number, and I'm going to prepend it again and again. So I have this roadmap here, and I'm going to apply it to router 6. So all my prefixes that I'm going to advertise to router 6 will have this change. So let's go to router BGP, and address family and PREPEND4, and for my peering with router 6, I will apply a roadmap that is known as peering with router 6 out. So I'm going to clear the session with router 6. I'm going to do it softly. And now let's see what happens with these routes that router 6 is receiving from router 1. So notice that now the routes that are coming from router 1 have this ASPAT. It is with the configuration I did, the ASPAT become larger. So when BGP performs its best path selection algorithm, it will come across these two destinations to the same prefix, two paths to the same destination, and it will have to choose which path is the best, and it will see at some moment that the ASPAT for this destination is shorter than this one, so it will pick this path. So the ASPAT, modifying the ASPAT will give you the power to influence the traffic, the ingress traffic. You might wonder, why didn't I use the local preference in this case as well? Sadly, the local preference is an attribute that cannot travel across autonomous systems. So no matter what local preference I set in this autonomous system, these other autonomous systems will always be unaware of that. So the ASPAT is an attribute that can travel through autonomous systems, whereas the local preference cannot. So I had to use the ASPAT in order to influence the ingress traffic. So if I try to reach router 1 from router 6, I will have to go through router 2. So using these route maps will help me influence the traffic. So I will use local preference to influence the egress traffic and ASPAT in order to influence the ingress traffic. That's it.